So here's my basic model for my motor. Let's break it down. So here is a diagram of my motor. Here's the 9-volt battery that I used to power this motor. The current in this motor will be traveling right to left. That's how this motor's been designed. So it's traveling up this wire to touch the commutator, and then we'll go through the coil, wrapping counterclockwise. I did this about 100 times for my final diagram, for my final motor. Then it'll go out the commutator and go back into 9-volt, making this a direct current motor. So then here is, I'm going to circle my commutator. Here's my commutator. As you can see, my commutator that's made out of copper here has some gaps in it. And in those gaps, I will explain this concept later of how magnetism works, and the machine continues spinning. It's going to be spinning in a counterclockwise fashion because the electrical current is running in that direction, so it'll be spinning there. And here is my scrub that I will be using to scrub bald Lego heads, hence the name bald head scrubberator. I still haven't come up with quite the name yet, and I will work on that for my final diagram. Then finally, here are the magnets I used. The 16-pound force neodymium magnets, 2 on each side. The north side was pointing towards the right, and the south side was pointing towards the left, hence allowing the motor to spin in a counterclockwise fashion. When electricity runs through a circuit, it creates a magnetic field. The repelling forces move. A break in the commutator allows for the charges to switch, thus repelling each other again and again and again. As the commutator and the opposing magnetic fields turn the shaft, it powers my scrub. Essentially, I thought that the problem with my design was that the wire was not coiled around enough and had to be redone. Moreover, I also realized that I did not sand my wire to remove the enamel coating. Oops. I also moved my magnets closer to generate an even stronger magnetic field. Again, the motor would not spin properly. It would make 2 rotations and then stop. Also, the magnets were too close and kept hitting the coil. For the commutator, I realized that they were too big and needed to be smaller. I also found I needed more flexible wires that connected the battery to the commutator. Success! The motor finally worked. Now, I added more flexible wires this time so that the motor would spin well, and I finally added the cleaner on the back. So now we can scrub bald heads. Thus, this bald scrub hedgenator electromagnetic motor was a success. What I learned about this? Well, I learned how much the flexibility of the wires affects the conductivity and how well it connects. I didn't know that. And also how many times I had to coil it around vastly affected my end product. Also, I guess my dad was right in recommending me to buy stronger magnets. I didn't really know how the strength of the magnetic field would affect anything. overall it was a lot to learn, really helpful. I think 3D printing the model myself and figuring out the designs really helped me to understand truly what these things, how the motor worked. And printing it with those 20-something hours definitely gave me a lot of time to think about development. Here are some very quick calculations of how much power my motor used and how much power my motor produced. In all, I think that it was a very fair number, with about 0.0468 watts used and about 0.02 watts produced. Not the most efficient motor, but hey, you know, first try, you gotta start somewhere.